Hey guys, this is Taylor here, and today we are solving the question number 3649, which is number of perfect pairs. This is the second problem of the biweekly contest 163. So let's get started. So you are given an integer array nums. A pair of indices I comma j is called perfect if the following conditions satisfied. Okay, so I must be less than j. Okay, and let a equal to nums of I and b equal to nums of j. Then minimum of absolute difference of a and b and absolute sum of a and b. Okay, minimum of, we need to take minimum. What minimum? We need to basically take the difference of elements. We need to take additions of element, and we need to take the minimum of it. This minimum should be less than and equal to minimum of individual a and b, absolute value of a and b. Okay, and maximum value of their difference, absolute difference, and absolute sum should be greater than equal to max of max of absolute value of a comma b. So, like for example, just for example, if I try to reduce what is given to us, so let's say it's given to us 4, and let's say -5 is given to us. What we need to, we need to take a sum of it. So what is sum? 4 plus -5. This will be basically sum. Okay. Need to take difference as well. Okay, let me take difference. 4 minus of -5. If I take, I think -1 I will get. If I take sum, I will get a 9. What I need to do? What is minimum of these two? I think I need to take absolute value. So I will make it absolute first of all. Okay, now what is the minimum of it? I think minimum is 1. Maximum is 9. Okay. So I need to compare this minimum. Is this minimum is less than or equal to this minimum absolute value? Okay, absolute. So I will take my absolute. I will make it plus. Is this minimum less than? Is this minimum 1 less than or equal to 4 comma 5, minimum of 4 comma 5? So yes, this condition is satisfying. Okay. So maximum I need to check again. Is this 9 is greater than or equal to maximum of absolute value of 4 comma 5? So yes, it's satisfying. So 4 minus 5 can be one of my pair. Okay, so this is basically what is given to us in the question. So what is written the number of distinct perfect pairs? We need to basically determine the count of this perfect pairs, and the absolute value refers to a non-negative value. So absolute value, I hope you guys understood. So if you get any negative number, you will get a positive number. If you get a positive number, you will get a positive only. Okay, so just we are taking positive. That's it. The second test case here, second test case from here. Now we'll try to understand, okay, how, what we can do. So very first thing, very first solution that must comes to your mind is we need to find two pairs, right? Either these two pairs, these pairs can be these two, or maybe these two pairs. That two pairs can be anything, and there is some mathematical condition that minimum of this. This is basically the mathematical condition. Both of the conditions should satisfy. Definitely write a brute force targeting each and every pair. And I will try to, like for every pair, I will try to check whether these numbers, this -3 comma 2, are satisfying that formula or not. If that's satisfying the formula, I will increase my count. Otherwise, I will not increase my count. Okay. So that is basically the brute force approach that will be taking the order of n square time. And we have given the constraints of 2 to the 10 to the power 5, so which is a huge number for n square complexity, and that will not basically work for this question. So what we need to do, we need to come up with some optimal solutions. So let's try to determine how we can come up with some optimal solutions. So just for the optimal solution thing, we need to make just a couple of observations. So the first observation that I am making here is, so like first input consideration that I should be careful about is, I have given both negatives and positive numbers. Okay. So this is the first thing, that my array can contains negative numbers as well and positive numbers as well. And so first of all, I would try to think about how these negative numbers can impact, like how far, how much these negative numbers can impact my solution. So I would try to, like when I was thinking of this solution, I tried a lot of examples to just see how these negative numbers and positive numbers are basically relating. What is the relation? Like definitely this is some formula which needs to be satisfied. So there must be some trick behind this. So I was just trying to figuring out that. So let me bring some two, like one or two examples so that I can explain you as well. So here I have written three test case. First test case contains minus 9 comma 5, second contains 4 comma 2, or third contains 6 comma minus 3. We will try to solve this. So if I try to apply the formula, my formula is, let me write the formula here. So my formula is max of basically a minus b, a plus b should be greater than equal to max of modulo of a comma modulo of b. And similarly for minimum, this part will be remaining same, modulo of a plus b, and but the change is it should be less than equal to minimum of this part also again same. Okay, so this is my formula. Let's try to apply this. So if I do a minus b, a minus a, minus 9 minus 5, what is the answer? I think minus 13. Okay, and absolute value will be positive. So this is basically difference. And if I try to calculate sum, I think minus 9 plus 5, it's minus 4. Okay, and if I try to calculate absolute value, it will get plus 4. Super. So what is the maximum of this? I think maximum is 13, minimum is for 4. So is this 13 greater than equal to max of this, max of absolute value of this? Max of absolute value is 9. I think your condition is satisfying. Is this 4 is less than equal to 5? Yes, condition is satisfying. Minimum is 5. So I think so. We are taking absolute values. Okay, don't be confused. We are taking absolute values here as well. Super. So let's try to find out solution for this. Okay, so max equal to, I think 4 plus 4 minus 2 will be 2. Minimum will be 4 plus, oh wait. Okay, so the summation will be 2. The difference is 2 and summation will be 6. So max will be 6, which is greater than equal to 4, and minimum is equal to 2, which is less than equal to 2. This 2, okay, this is this 2 and this is this 4. Super. So this condition is also satisfying. Let me try to change this test case. Let me take, let's say, 1 here. A negative 1 will also work. Super. So let me try it out. So what I will be doing, I will be calculating the difference first. So 6 minus of minus 1, which will become 7. Okay, plus 7. We are putting this formula. Now this formula. So 6 plus 1 and 6 plus negative 1, which will give us 5, and it's a positive 5, no issue. So what is the maximum value? I think maximum value is 7. There, that is fine. And what is the minimum value? I think minimum value is 5. Okay, 5. Is this 7 is greater than equal to 6? Yes, it is. Is this 5 less than equal to absolute value of this, minimum of this? I think 1 is the absolute value and minimum of this. So is this satisfying? I think no, this is not satisfying. Okay, so basically this is basically the couple of examples. Now if I do one observation, if I do something like this, 9 or minus 5, if you try it out now, you will again get this as answer, and this condition is still satisfying. If you get something like this, minus 9 minus 5, the condition will still satisfy. Answer you will still get as a count equal to 1. If you get something like this, 9 comma 5, the condition will still satisfy. So the first observation is sign doesn't matter. Okay, so first observation is, so observations are, sign actually doesn't matter. Okay, so let me write it. Sign doesn't matter. Superb. So this is my first observation. Now I need to try to determine some combination, like not combination. I mean some like what is bringing. There should be like some range. So what I have observed here is 5 versus 9. Okay, like let's deal in only positive numbers. So just to make everything very simple to understand. So I had one pair of 9 comma 5. I had one pair of 2 4 comma 2, and I think 6 comma 1 was another pair. Super. So 5 versus 9, it was working, and then this was giving me one answer, one pair. 4 comma 2 was working. 6 comma 1 was working. If I try to go here, I'm just teaching you that how to come up with solutions. Okay. If I observe here, was 0 comma were in the answer. I don't think 0 comma 1 is not in the answer. 1 comma 2 was in the answer, 2 comma 3 was in the answer, and 1 comma 3 again is not in the answer. Okay, so let's keep it, so now let me see. So 3 comma 2, okay, we will just deal in positive because we see that negative or positive doesn't actually matter. So 3 comma 2 was the answer, and 1 comma 2 is answer, 3 comma 4 is again answer, and 2 comma 4 is again answer. So one observation I can make is, see, sequentials is always working except 0. Sequential is always working 1 2 2 3 here, 3 4. Sequentials were always working. Okay, sequentials are always working. One more thing, 2 comma 4, 2 comma 4 was always working, 2 comma 4 was also working, 2 comma 4 also working. Okay, now, so if you try to basically try some pairs like this, if I let's for clarity, let's do one thing. Okay, let me write a range: 1 2 3 4 5 6 7 8 9 10. I think till 10 it will work. So if when I was dry running, I was just checking that for one how far I can go. I checked that 1 comma 2 was working. Super. Okay, for 2 I checked that 2 comma 3 was working, 2 comma 4 was working. Okay, superb, superb. Now I check for 3, 3 comma 4 was working, 3 comma 5 was working, 3 comma 6 was also working, but 3 comma 7 was not working. So can I let's check for 4 as well. 4 5 working, 4 6 working, 4 7 working, 4 8 working, but 4 9 not working. So can I deduce something from this? I think my observation is, whatever the smaller number is, okay, smaller number into 2, okay, into 2. So the largest number that can take up. So 2 into 2, 4. 2 comma 3 was working, 2 comma 4 was working. Itself 2 comma 2 itself was working. Okay. So from that number to the set, like double of it, to the double of it. So if I'm trying to figure out for 3, okay. So how far I can go? I think 3 comma 3 I can go. Yes. 3 comma 4 I can go. Yes. 3 comma 5 I can go, yes. 3 comma 6 I can go, yes. Absolutely I can go. But 3 comma 7 I can't go. I can't go because it's larger than the double. Okay. So that was just the basically the observation here. So what is my case? Like B should be I think I can write something like this. So my A should be less than or equal to 2 into B. How? So A should be 2 and B, okay, I wrote, I think, opposite. B should be, my formula is B should be less than or equal to 2 into A. Okay. So this is basically my formula. My B should be, if my B lies in the range of 2A, it can be A from A to 2A. Okay. If B lies in this range, then my solution will definitely, that can be my perfect pair. Okay. So what is the valid range for B? I think A to 2A. This is my valid range for B, where A is less than B. Okay. This is condition. A is less than B, and this can be my condition. Okay, so okay, I have figured out that I can, like, what is the condition, like I have given this long condition, right? This long condition. So I have come up with a small condition where, what is the condition? A should be less than B. This is first thing. Okay, this is first thing. Second thing is, B should be less than or equal to 2 into A. Okay, if these two conditions are satisfying, that means my perfect pair can be found in this array. So how can I solve this problem? So if we talk about the approach of this problem, how will be solving this? So the first thing I think I can do is, basically, from this array, I think my, like, solution, my pair finding becomes really easier because this array was sorted, but this was not sorted, right? So I think I can sort array. And how I will be sorting that? I think sorting will be based on the absolute value of this. So if I'm getting 1 2 3 4 now, so I will ignoring this negatives. Okay, I will be just sorting based on the absolute value. So if I do such 1 2 3 4, I will get this. Okay, I will get something like this if I sort this array. Super. Now what is the next thing I need to do? I need to figure out, basically, again, if we think in a brute force manner, by just putting these two formulas. So my A should be less than B. Okay, A is less than B. Super. Is my B is less than equal to 2A? So this is my B, this is my A. Is this satisfying condition? So 2 is less than equal to 1 into 2. So 2 is less than equal to 2. I think the condition is satisfying. So 1 comma 2 can be my perfect pair. Super, super. 1 comma 2. Okay. Now I will try to check for 1 comma 3. So 3 is less than equal to 2. No, it's not a perfect pair. So okay, I will stop. I will stop. Why I will stop? So 1 comma 3 is not working. So how 1 comma 4 will work? Super. This is again a brute force way, but that will definitely help us to come up to bring a optimal solution. Super. What is the next thing I think I can start from two. I will check okay, whether it's working for three. Let me check. So I will write a three. This three is actually B less than equal to 2 into A. What is my A? My A is basically 2. So 3 is less than equal to 4. Yes, it is. Yes, it is. I can get my answer 2 comma 3. Let me write it. Superb. I can increase count. So I don't need to return indices or numbers or anything. I just return a count of it. So that will be easy thing for me. I'll try to move here. So whether 4 is less than equal to 2 into 2 is 4. So yes, it is. So this can be my answer 2 comma 4. Superb. I think I am done. So I will try to calculate for 3. So 3 comma 4. Let's try 3 comma. I think 4 should be less than equal to 3 into 2. It's 6. I think condition is satisfying. So 3 comma 4 can be my one of the pair. Now my array is ended. Super. So this is again a brute force approach. What I was trying to do, I was trying to like let's say for example, I'm having this long array. Okay. So what I'm doing if let's say I'm present at 5, I'm trying for five like five trying from 5 to 6, 5 to 7, 5 to 8, 5 to 9, 5 to 10. And as soon as I got 5 to 11, which will not work, I will stop. So that is kind of again n square solution, right? So what I need to do, and I try to optimize this. So I will just make one more simple observation. My observation is, let me write down the array. I think observation is simple. Once you get it, it will be very easy for you. So observation is superb. So we have enough larger. What is the observation? If I am let's say 3, okay, I have checked for 6. I have checked for 6. Superb. Now when I checked for 7, it doesn't work. It doesn't work. So I have to calculate answers from there. So I try to check 0, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11. Superb. Now I was here. I checked that till here it was working. Okay, so 7 it was not working. So if I try to calculate how many pairs I getting 1, 2, 3 pairs I got, right. So if I try to evaluate 6 minus 2, I got 4, right. I got 4. If I write minus 1 here, I got 3. So can I write something like if this is my I loop, this is my j loop, okay, or maybe this is my start pointer and this is my end pointer. Can I write something like this? And minus start minus 1. If I write something like this and minus start minus 1, can I get all the pairs which are starting from 3 and which are ending to 6? I think yes, this can be my answer. If I check for 2 as well, okay, let's try to check for 2. Okay, so my 2 is here and my actual pairs are 2 comma 3 and 2 comma 4. Superb. Now I tried this and when I tried this doesn't work. Okay, so 4 minus 1. Superb. Minus 1. How much I get? I think I got 2 and this is also 2, right? So I think this way, this formula, let me write the formula. So j minus I minus 1. This can be my answer for the current window. This is basically a sliding window problem. So or I can write for clarity and minus start minus 1. This is window end, this is window start, and this is minus 1. Now in brute force approach, what we were doing, we were basically when I checked for here, na, when I ever started for the next window, I started from here, right? But the observation here is if I start from here itself, right? So when like what is my end of the window? If I start from there itself, na, then also my answer will be valid. Why? Because 3's double is 6, which is greater than that. So my 2's window was ending here, right? My 2's window was ending here. But when I check for double of 3, na, what is my like just greater? 2's just greater is 3. So if I check for double of 3, it will be much greater. If I check for let's say 3's window is ending here. If I check for 4's double is lying like here. 5's double is lying here. Okay, so it's far, right? So four's window was here and 5's double was here. I think the next number's double is far. So I can definitely reuse the values. What reusing? We are basically reusing the end window. So if for 2 my window is looks like this, start is here, end is here, and my end reached here. And when I started to calculate for 3, can I keep my end window here itself? Yes, I think I can keep. So I will move here. I will check. This is still satisfying. I will move here. I will check. This is not satisfying. So I will calculate my answer. Simple. 6 minus 2 minus 1. Simple. So this way. So 1, 2, 3, 3 pair I will get. So that's the basically intuition behind the approach behind solving this problem. So let me try to write pseudocode for this quickly. So pseudocode will be simple. I think I will get the length in this n length of nums. Super. Now I will start my start pointer from 0. End pointer will be again, I think I can keep it at 1 at 1. From 1 I think I can start. Super. So what is the next thing I think I need to do? I need to run a loop. So I can write a for loop as well. For start equal to 0 to n. And what is the next thing I need to do? I think I need to check what I need to check. I need to check like if my start is here and considering my end is here, so how far I can go. So I think I can go b is less than equal to 2a. So let if I write something here in that manner. And before that we need to sort the array. So here we will be writing sort array on absolute value. Okay, this is very important step. Okay, super. So this is start pointer. This is basically end of a start pointer. Now my end, I am starting end from 1. So what is the next thing I need to do? I need to check while end is less than n. Okay, this is must condition, and nums of end is less than equal to nums of start into 2. Okay, 2 into nums of. So like till time this condition is satisfying, I can do and plus plus definitely. Superb. Now what is the next thing I need to do? I need to calculate my answer. So I will increment, I will write some answer here, and every time I do something like this I will increment answer. And minus start minus 1. Why I'm doing this? Because like end minus start minus 1 is basically my window size. I hope you are able to understand. So we are basically, if we are having window like this and our end is present here, so what, how many numbers? I think 1 and 2 numbers are there. So 4 minus 1 is basically 3, and minus 1 if I do, I will get a 2. So basically I will get the numbers here. Okay, how many pairs I can make starting from 2 ending to 4, ending till 4. Super. And I think we are pretty good to go, and we can definitely return our answer here. Return our answer. So let's try to code this same logic. So n would be length of nums. First of all, now I need to sort my array based on absolute values. Okay. So in Python, I can write something like this: x is the absolute value of x, and equivalent C++, Java, and JavaScript code is in the description. If you write in those languages, please make sure you can watch those along this. So what is the next thing I need to do? I think my end can be starting from 1, and for start, I will be starting start in for loop itself in range n, I think. So it is basically 0 to n minus 1. Okay, super. Now what is the next thing I need to do? I need to check whether end is less than n, and nums of absolute value. First of all, absolute value of nums of end is less than equal to 2 into absolute value, 2 into absolute value of nums of start. Simple. If this is satisfying, then I can increment my end pointer. and as soon as my condition is not satisfying, I can put it in my answer. Simple. Answer plus equal to and minus the start minus 1, and I think I can return my answer in the end of that. So this is basically the whole approach. Let's try to run this and see whether it's working fine or not. Okay, we are getting some wrong answer. We are getting one more. What is the issue here? Okay, I did a silly mistake here. This absolute value will be here. I think bracket mismatch, something happened. Okay, so if I try to again run this, this will work fine. Okay, it is working fine. Let's try to submit this and see whether it is working fine or not. So yes, it is working fine. So I hope I'm able to explain you like from root force to this optimal solution how we come, and the main thing to focus here is basically just the window, and we need to make some couple of observations. The first observation is b should be less than equal to 2a. If you are able to come up this, you have solved the half of the problem. 50% of problem is solved if you are able to understand this. And the next problem you are able to solve if you try to see that if you are able to solve it brute forcefully, that for 2 you have to go till here, for 3 you have to go till here, 3 to 4, 3 to 5, 2 to 6. And the second observation was here is from 2 if you reached here at 5, from 3 you don't need to start from here, you can definitely start from here itself, because this 5 must be less than this double of this 3. Okay, so I hope you are able to understand what we have discussed in this video. In case you like the video and if you are understood what we have discussed, please make sure you subscribe the channel and like the video. That will definitely motivate me to create more such videos. So thank you very much, guys, and we'll meet in the next.
Hold me close till I get up. Time is barely on our side.